Welcome to our presentation. We are AGM Construction, here to present to you our proposed sustainable retrofit of the Elton Mayo Building.
The Elton Mayo Building is located in the City West campus of the University of South Australia and is a dwelling which was built in 1997 for the use of educational purposes and is a large facility with a floor area of 2,189 metres squared. The Elton Mayo Building is largely as originally constructed with only internal refurbishments, and is evident that there is currently a dire need of sustainable retrofit in terms of the building and the environment. The surroundings of the building are a particularly new and modern environment and don't necessarily complement the current design of the building.
Why should you retrofit? I'll tell you why. Firstly, future cost savings. Operational energy and water use can be reduced by incorporating new technology, services and equipment over the lifetime of the building, making them cheaper to run in the long term. Furthermore, increased comfort and well-being to occupants. Building facades and interiors may be redesigned, improving occupant well-being, satisfaction and productivity by improving thermal comfort.
Other benefits of why you should retrofit using sustainable construction include the improvement of water usage and decrease of greenhouse emissions, by reducing reliance on traditional means of energy and water, thus contributing to lower greenhouse emissions and improved water self-sufficiency. In addition, by future-proofing buildings, it will meet current demands of technology, energy and water use, ensuring that they last many years into the future, without needing to be demolished and rebuilt. Buildings have the opportunity to be relifed and their current life cycles extended into the future.
Last but not least, maintaining cultural and heritage significance. Buildings that have cultural and heritage significance can still retain these over their facades or building envelopes, with interiors refurbished so they can meet current standards and expectations of design, functional use, technical requirements, and lower footprints in terms of resource use. The image present shows the gas and water consumption taken from the past 5 years of the Elton Mayo Building. It can be seen from the table below that the gas consumption has increased significantly over the past 5 years. In 2012, the consumption was 205,206 megajoules and jumped up to 206,564 megajoules in 2013. Not an overly big increase compared to the following year in 2014, where the gas consumption was 296,315 megajoules. In addition, the 2015 year's gas consumption was considerably very high at 362,944 megajoules. The following year in 2016 showed improvements as the gas consumption decreased to 357,292 megajoules. Major contributors to these levels that would be related to the Elton Mayo Building would include kitchen appliances within the building, or possibly hot water if it is run by gas in this case.
In addition to this, the potable water consumption from the image shows various results from the past 5 years. The first recording, taken in 2012, shows a potable water consumption of 1,267 kilolitres and gradually increased to 1,276 kilolitres in 2013. 2014 showed improvements by decreasing to 1,222 kilolitres, although the following year reached its highest consumption levels of 1,324 kilolitres. 2016 water consumption for the Elton Mayo Building managed to consume the lowest potable water usage in the past 5 years of 1,204 kilolitres.
The building's baseline for energy consumption has been recorded from the past 2 years, and from the image present, it shows interesting results. The energy consumption from 2015 was recorded as 275 megawatts and 126 kilowatts. And 2016 results, so the energy consumption was 265 megawatts and 121 kilowatts. Therefore, the energy consumption shows an average of 270 megawatts and 123 kilowatts over 2 years. Whichever means were undertaken in 2016, the energy consumption from the Elton Mayo Building improved from the previous year.
Our team at AGM Construction believed that by retrofitting the Elton Mayo Building, we could improve its water consumption by 10% in order to meet the Green Star energy rating, primarily through plumbing fixture replacements and implementing new technologies. An example for this can be achieved by replacing older, high-flow water closets and flush valves with models that meet current requirements. While current codes require the lower flow rate for new fixtures, existing buildings often have older, high-flow flush valves.
Additional ways energy can be improved. Taken from the information from the Elton Mayo Energy Report, the energy consumption did improve from the previous year, although we, AGM Construction, believe it can improve further. We believe the Elton Mayo Building could improve its energy consumption by 10% in order to meet the Green Star energy rating. This can be achieved by some simple ways such as insulation, using high-performance insulation and non-traditional wall systems that offer additional insulation. The insulation should make the building as airtight as it can be. Similarly, the use of LED lighting. It is known that LED lighting has the ability to reduce energy consumption by 75% compared to the standard lighting. AGM Construction uses a well-known rating tool which highly improves the sustainability of the Elton Mayo Building. Green Star interior credits, enforced by the Green Building Council of Australia, depict the majorly positive benefits it could have on your building. The statistics are impressive and achieve a high amount of sustainability throughout the longevity of the development, as seen in the image.
On behalf of the AGM Construction team, we would like to thank you for providing us with the opportunity to pitch a sustainable retrofit to the Elton Mayo Building. We hope you can consider our proposals to take a positive step into a more sustainable environment and a sustainable future for the university facility. Thank you from the members of AGM Construction, Anthony, George and Melinda.